Well, welcome everybody. We'll get started now. My name is Dana Duke. I'm the Executive Director with the Miistakis Institute. And today for our Miistakis Monday webinar, I will be presenting on citizen science. So specifically advancing citizen science in Alberta. And so as we get started here, we're just going to go just a brief tech overview using this Zoom platform. And so the way we'll be interacting today is that you are all muted. And so I'll be the person you're hearing from, but I'm hoping we will have time at the end today for any questions that you might have. And you can contribute your questions using the chat box for questions there. And then I ask that just when you go to the chat box, if you could address your questions to all panelists and attendees so that everyone can just see your questions. I'll try to repeat them as best I can, but it's just helpful if everyone can see them. I'll start off, for those of you who don't know the Miistakis Institute. Miistakis Institute, we're a not-for-profit, charitable, applied research institution, and we have a formal affiliation with Mount Royal University. And at Miistakis, all of our research at Miistakis is really about getting information into the hands of decision makers so they can use it in support of conservation and healthy landscapes. And so today I'm going to be talking to you about citizen science. So I thought I'd just start off by just talking about what is citizen science. And this is a tricky one actually, because there's actually been a lot of efforts to define citizen science. And what people have come up is a working definition, which is projects in which volunteers partner with scientists to answer real world questions. And there was actually quite an effort in 2014 at the Citizen Science Association conference. There was a lot of discussion around defining citizen science, and that what they realized is that there's actually a lot of different names for engaging the public in science. And some of those are listed here that we talk about: public participation in scientific research, participatory action research, community-based monitoring, and volunteer monitoring. And sometimes people think of these as some of these terms as different than citizen science, but I think what's more important is to think about the common elements of citizen science, and that and what some of these common elements are is that data collection, the data being collected is useful. It's that volunteers have a meaningful role to play, and that there's a connection to an agency or an academic institution or that scientist body. And it's often that this collaboration between them is that it goes beyond the institutional boundaries of where you're addressing a common agenda between multiple actors or different stakeholder groups. And also in citizen science is that there are these typologies across different types of citizen science. And one of those is that scale, or the level of geography. And so what we see in citizen science is this can be really broad. It can range from local, like city, regional, all the way to countrywide, continental, and global. And that these different levels and these different geographical scales, they lend themselves to different kind of modes of participation and how volunteers participate. And we find that as the scale increases, like from local to global, the role of individual participants in the whole scientific process diminishes. So if you have kind of the difference between a local watershed group that's monitoring a local creek, right up to kind of national or international efforts like eBird, where we have naturalists reporting birding observations across the world. And that the larger the scale, the more formal the organizational structure is needed for that type of citizen science. Now, what we also see another typology with citizen science is the disciplines themselves, that there's this broad range of disciplines that citizen science address. We have citizen science that addresses astronomy, biodiversity, history, literature, climate, and social science. So a real wide diversity there. And then what we also find in citizen science are these different levels of engagement. And they're often defined these three different ways. One being contributory, and contributory are often citizen science initiatives that are designed by scientists and for which volunteers really only, their contribution is contributing data. And then we have collaborative projects, which are generally designed by scientists and for which volunteers contribute data, but they can help refine project design, they can help analyze data, and they can help with dissemination of results and findings. So there's a bit more engagement with collaborative citizen science projects than contributory. And then we also have co-created, and that co-created projects are designed by scientists and volunteers working very collaboratively together. And then some of the volunteers are actively involved in most or all aspects of the research process. So this is a very integrated process, co-created citizen science. There aren't that many, there's far more contributory and collaborative citizen science projects than there are co-created. And then we also see a real diversity in the types of volunteer activities. So this is the actual things that volunteers do as they're involved in citizen science. And so also with citizen science, what we see is a real, we look at the value of citizen science from both the science perspective and from an engagement perspective. And so this slide here just talks about some of those science outcomes that we see with citizen science. And one of them is that citizen science can address large scale data needs. So we find that citizen science can operate at greater geographical scales and over longer periods of time than some conventional science can. And just an example of this, there was a number of researchers collaborated together on a piece of research in 2015, and they looked at 388 different biodiversity-based citizen science projects. And across those 388 projects, they saw that estimated between 1.36 and 2.28 million people volunteered for those projects each year, with each participant spending an average of 21 to 24 hours collecting data. And they saw that contribution averaging around having a value of between 667 million and 2.5 billion of in-kind contributions. And they saw that kind of all those projects together yielded a total of 446 scientific publications. So it just really ramps things up across these scales. And we find that citizen science can speed up and improve field detection. So it's just more eyes on the ground. And that can be really effective at detecting change and reporting on rare events, which are sometimes impractical for more traditional scientific endeavors. Lastly, it can improve data and image analysis, and that we've seen that volunteers are really effective at classifying photos or videos and audio files, as well as reporting on different types of secondary information. So greatly speeding up data processing and analysis. And so that can result in great cost savings and processing time, and which are really important for consideration for monitoring agencies that really are trying to report in timely and in efficient manners. So those are just some of the science outcomes that we see with the value of citizen science. And then we also see all these engagement outcomes as well. That primarily citizen science, we see that it really enhances the flow of information. That information is generally passed from agency to the public by outreach and education mechanisms. But citizen science programs differ in that volunteers participate in the research and monitoring and generate knowledge through that participation, thereby changing how information flows. And this leads, and we've seen this, how it leads to increased public participation in decision-making and better outcomes. And with ultimately, the desired outcome of monitoring programs is to provide information necessary to understand environmental conditions and inform decision-making across the board, like by policymakers, planners, researchers, industry, even the public. So a more open flow of information just through increased participation by the public and understanding of issues can benefit monitoring agencies and the participating volunteers. So we see that citizen science also leads to an improved understanding of science, and also the ability of science to answer the questions that we're posing. And so it really just lends to this improved scientific literacy. It can also result in more engagement of people in decision making, and it can lead to environmental stewardship. And so in some cases, we see that stewardship actions by participants that actually may be what one of the outcomes are from a citizen science program. And there's lots of examples of volunteers actually undertaking stewardship activities as a result of what they learned through their participation in collecting data. And an example of that is there's a program called Monarch Watch, where citizen scientists contribute their observations of monarchs as monarchs are traveling down to their migratory routes. And what they saw is participants that were contributing their data actually resulted in behavioral changes for a number of those volunteers, where they started planting pollinator gardens in their backyard as a direct result of participating in the program. And we just see how citizen science can address local concerns, that it's often citizen science programs come to be because of a concern that is brought to the attention of scientists from locals. And it improves collaboration. We just see these synergies that are created across between scientists, agencies, and the public. And it really results in this building of trust across that. And what this graph shows here is it shows the number of peer-reviewed publications that reference citizen science from 1995 to 2015. So you can just see in those last 2 decades, citizen science approaches to gathering, and this is specifically biodiversity and natural resource information, has really grown. And there's researchers have identified a number of reasons for this. One is just the evolution and accessibility of technical tools. A lot of that is, mobile apps really facilitate the collection of information and dissemination of information. And secondly, just a greater appreciation by professional scientists and others that the public represents a real valuable source of skills, labor, computational power to be contributing to citizen science. And also an increased value realized that by improving the public's understanding of research and monitoring through engagement in the scientific process. And so we've also seen this as in publications as well. You're starting to see more and more discussion about the value of citizen science as well. And so at Miistakis, we use a citizen science approach to generate data to inform a wide variety of conservation challenges and to help to create a knowledgeable and engaged public and citizenry. And at Miistakis, we develop different tools and frameworks to contribute to different successful citizen science projects. And so we've been using citizen science for over 15 years now. And we've used citizen science across a number of different conservation challenges. And I'm just going to give some examples of how we're using citizen science and how we feel it's contributing to conservation outcomes. And then I'm going to talk a bit about some of the lessons we've learned through that work as well. And so one of the, this is a project where we have used citizen science. It's called Collision Count. And Collision Count was a program that was developed to gather data on wildlife road mortality that was not detected with traditional road surveys. So traditionally, cost-benefit analysis of animal vehicle collisions are based on road mortality data. And that's really by people doing road surveys where they drive the road and document where they're seeing animals that have been killed by vehicles. However, that road mortality is greatly underestimated, because we know that a lot of animals are hit on the road, but then they wander off and die of their injuries off the road right away. And so we designed a citizen science program where we had citizen scientists collect information on road mortality away from the road right away. And so we had citizen scientists walk transects. So you can see on this slide, that third image there, that's a kind of a representation of these transects ran perpendicular. Well, they were 50 meters off of the road right away, and then they ran parallel to the road. And so citizens would walk these, and then through, we had a mobile app that facilitated the data collection to document mortalities they were seeing. And this project ran for a number of years. And what we found was that we were able to use that information to actually calculate a correction factor. And that correction factor, we calculated as being 2.6. And so what this did is it changed the cost-benefit analysis that we that were being undertaken for animal vehicle collisions along the road, and it allowed us to kind of look differently at different road segments and what their cost benefit would be to actually mitigating that highway for wildlife. And so we see this as a real valuable contribution to the field of road ecology, and something that citizen science played a really important role in. Another example of a citizen science initiative, this was a program that we developed to monitor grizzly bears in the lower Peace region in Alberta. It's called Grizz Tracker, and it's a partnership initiative between Alberta Environment and Parks, Miistakis, and various industrial stakeholders. And so this grizzly bear data collection is facilitated through a mobile app, and the mobile app was created, and also there's a unique functionality that was built into this that greatly enhanced the data. Often one of the challenges we find with citizen science data is that it's often just opportunistic data. It's when somebody's out there, they see something, they document it, and it's recorded. But there's very little known about the effort that's undertaken and how long someone was out there before they saw something, or how many times they were out there and they didn't see anything at all. And those are two both really important criteria when you're using that data to do any kind of modeling. And so we built into the functionality of Grizz Tracker the ability to record effort. And that was through this route functionality. And so participants were able, you can see on this first image here, it says trip in progress and end trip. So someone would use this mobile app and actually start a route, and that just ran in the background. And so people who were on different resource roads up in the lower Peace, the app would just be calculating that in the background. And then if they saw a grizzly bear, they would be able to document that. But that attached to that record was actually their route. So we were able to then calculate as a function of how long they were out there and the distance they went, the relative amount of observations of grizzly bear. So it just allows us to normalize the data to effort, which just makes the information gathered much more useful. And so another initiative which we use that same type of functionality in terms of being able to calculate effort of citizen scientists was with a program called Pronghorn Crossing. And Pronghorn Crossing was designed to gain a better understanding of where pronghorn are crossing roads, so we can mitigate roads to provide pronghorn the opportunity to cross roads more safely. And so, like I said, similar to Grizz Tracker, pronghorn crossing has this route functionality, which allows us to normalize the data to effort. And excuse me, this just shows an example of how the results from pronghorn are being used. It allows us to really combine the data with other data sources, to have a more fulsome dialogue about mitigating roads for wildlife. And so what this shows is that the alignment between kind of motorist safety from an animal vehicle collision perspective and pronghorn movement. So citizen scientists are out there driving routes and documenting when they're seeing pronghorn adjacent to or crossing roads. And we're able to then combine the results of pronghorn crossing with connectivity models and animal vehicle collisions to start to identify these sections of highway that we need to be thinking about from a mitigation perspective. And so this graphic here shows where we had pronghorn movement agreement between like pronghorn citizen science data and connectivity models, and then also where animal vehicle collisions are highest, primarily driven by deer, but allows us to then, if we were to use any one of those data sources in isolation, we would have a different picture. And so I think when we start thinking about these different data sources, we can look at the highway more holistically and addressing more wildlife movement needs. So this is another program, Call of the Wetland, that Miistakis has developed in partnership with the City of Calgary, the Friends of Fish Creek, and the Glenmore Weasel Preservation Society. And oh, I'm sorry. No, that's our Calgary Captured program. I'm going to get to that in a minute. Call the Wetland is a amphibian monitoring and wetland monitoring program that we developed in partnership with the City of Calgary. And this program is designed to monitor wetlands within the City of Calgary, recognizing that wetlands play an extremely important ecological function within the city. However, there's very little known about the amphibians, what amphibians we have and where. And so we designed a citizen science initiative where citizens would go out and document a number of pre-selected wetlands, and citizen scientists would sign up for a specific survey period, and then they would go out and document both what they saw and what they heard facilitated by a mobile app. And this program's run for 3 years, and we're using that, oh, sorry about that. We're using that information to just determine what species of amphibians we have where. And so we've determined we have 3 different species in the City of Calgary. We know that 3 other species we have not detected, and now we're using this information. We're doing different occupancy modeling and connectivity modeling, one of the things I wanted to point out about Call the Wetland was that how important it was for us to get feedback from the volunteers about how they were sharing the information about the program. And so we surveyed our citizen scientists that were participating in Call the Wetland, because we wanted to get a sense of what information they were sharing, because we had certain engagement objectives that we had with Call the Wetland. Call the Wetland we designed because, one, we wanted to know more about amphibians in the city, but we also wanted to engage citizens in this important dialogue about the importance of wetlands, recognizing that we're losing wetlands within the city at an alarming rate. And so this type of kind of engagement with volunteers we found really important, because this feedback was telling us that while there was information sharing going on, and what this graph shows is just the types of information and how many people were sharing those types of information. You know, the types of things they were sharing the most were things like general program information. They did encourage others to join. And they talked about the smartphone app itself. But you can see the numbers were lower for things about understanding of city wetland planning, general urban wetland knowledge, concern for wetland health or loss, the things that more closely aligned with what our objectives were. And so this just really helped us refine our messaging and how we had to go about engaging with our citizen scientists if we were going to fulfill our objectives, our engagement objectives. And this is another program that Miistakis, and this is where I jumped the gun. This is a program we've done in partnership with the City of Calgary, Friends of Fish Creek, and the Glenmore Weasel Head Preservation Society. This is called Calgary Captured. And this program was just designed to increase knowledge on our urban wildlife in the City of Calgary, ultimately to inform development and management decisions, but as well as to engage the community on urban wildlife. And so we have a number of cameras, over 60 cameras set up in all different City of Calgary green spaces to document images of wildlife. So as you can imagine, there's thousands upon thousands of images of wildlife that we collect, and where we engage citizens is in how we categorize all of those images. So you can see in this here, you can see it's very small, but in the right of this slide here, we use a platform called Zooniverse, which is it's a citizen science platform which houses dozens upon dozens of different citizen science projects. But Calgary Captured is housed on this Zooniverse platform where people from all over can go and classify our images. And so they do that by just using the Zooniverse platform and telling us what they saw, how many they saw, and that all feeds back to our database. What's really unique about Calgary Captured and the Zooniverse platform is kind of the reach that then we have. And so what this slide shows is, you can see at the bottom what's highlighted in that red box there is, this is the number. So we've had just under 4,000 volunteers participating in Calgary Captured. And what's really interesting is those aren't all from Calgary, and that we did an earlier breakdown and we saw that about between 60 and 70% of those people were from Calgary, but then we had international participation in this project as well. And you can see here, you know, they've contributed to over 175,000 classifications. So again, just lending back to what we said before about how citizen science from these scientific outcomes can really lend to, you know, manpower and how you're classifying images. This would take, this you know, calculates to thousands upon thousands hours of manpower of classifying images. And it allows people to participate in without ever leaving their house, which isn't possible for some people. So some people, this allows people to engage in wildlife, urban wildlife and ecology issues without actually necessarily having to leave their house. And so, like I said, I was going to highlight some of the lessons through all of these programs that we've undertaken with our partners. There's a number of lessons we have learned, some hard lessons, some trial and error that we feel that we would like to share, because I think these are really important lessons for others also who are thinking about undertaking citizen science initiatives. And so the first one is that it's important to address that tension that exists between your science and your engagement goals. That I think it's really important that you have both science and engagement objectives, but recognizing that each of those requires a very specific methodology, expertise, and evaluation. And that realize that one may compromise the other, and that you may need to then reevaluate your science or your engagement outcomes based on that. but that the real true value of citizen science really comes with that marriage between those two, and that one doesn't take priority over the other. And I'll just, I can give an example of that. So with our Call of the Wetland program, one of the tensions we had in this is that we had decided not to share the results of where we were seeing certain species until the end of the 3-year data collection. Even though we knew our volunteers would have liked to have heard about that, we just felt that if we did, it might have biased our data collection, as volunteers would, they may select wetlands to survey based on the probability of seeing a species of interest. If we let everyone know right away where we saw tiger salamanders, we may have skewed then how people selected which wetlands they were choosing to survey. So posting our results may have bumped up our volunteer engagement, but it may have compromised our scientific rigor. And so that's just about where one might compromise the other. And another example of this tension is with the same program, is that scientifically, it would have been best to have each volunteer sign up for 9 amphibian surveys, as this is what was required as part of our sampling methodology. However, we just thought from an engagement perspective, it'd be best to be flexible and let volunteers decide how many surveys they wanted to do. So this resulted in us, we actually ended up hiring a summer student to kind of fill in those gaps that were undersampled. But we felt from an engagement perspective, you need to give volunteers the flexibility to go to the wetlands they want when, and not kind of force volunteers into that. So this is something as well that there is a really broad range of diversity of skill sets that are required for successful citizen science program design. And so this just kind of highlights the different ones. But so right from program design to implementation to evaluation, that there's a real broad range of skill sets that you need for successful citizen science programs, and not one person is going to have all of these skill sets. So it's really about finding out how to get all that skill sets you need for successful implementation of citizen science programs. Another really hard lesson we've learned over the years is the importance of getting the technology right. That technology is great, and that can really enhance your data collection, but it's really tricky. Something too that we've come up against over and over is that a mobile app on your phone is not a citizen science program. And we've been asked at Miistakis many times, can we use that app, or can you build us an app for this? And we always try to link that back to, well, what are your objectives of your program? What are you trying to achieve here? And that an app is a tool, and it facilitates data collection, but it is not a citizen science program. And that your technology needs to be driven by the goals of your program. Another one is that you only get one shot at releasing a piece of technology, and so you really have to get it right. That if you release something and it doesn't work, or people find it problematic, bringing people back to that is really hard. And so it's really important to get that right. And so in order to do that, Miistakis, we have undertaken usability testing quite often through when we develop different tools to support data collection, specifically mobile apps. And so we have used usability testing experts to help us in this, to design surveys and testing for people to do on our different tools. And so this is just an example of the types of survey results we would get back, that people would tell us if certain functionalities were easy to use or hard to use. And then we would, before we released a tool, we would go back and make these adjustments to make the tool as user-friendly as possible. And I can't emphasize enough how important this step was for us, that things that we thought were intuitive were not. Like, we thought there was one tool we developed once, and we thought we had this very visible big red button that we thought, you know, for people to actually submit an observation. And, you know, when we got that through testing, and it turns out it was not intuitive to anyone. And so this is really critical for us. This is just an example of Miistakis. We worked with Brian Traynor at MRU on this publication about how building user experience design into citizen science applications, and the importance of that. Another important lesson we learned is the importance of establishing data quality and validation into your program itself, into your actual program design. And that, you know, citizen science projects, they have huge potential to advance scientific knowledge, influence policy, engage people, but the data has to be really sound. And there's a lot of things that you can do to ensure that, and to boost data accuracy and account for bias. And that includes iterative project development, volunteer training and testing, expert validation. We built that into a lot of our tools. Like, for example, people were able to submit where they were seeing animals cross roads in a program we did down in southwestern Alberta called Road Watch in the past. But we built into that expert validation where if we actually saw a rare species or a species of concern, like a grizzly bear, a wolf, or a cougar, an automatic alert was sent down to wildlife experts down in the area so they could go out in the field and validate that observation. We've built in replication across volunteers. So, for example, in Calgary Captured, the program I talked about, where we're taking photos of wildlife in the city of Calgary, and those are classified on the Zooniverse platform. Those images have to be classified by a number of different volunteers before that data is entered into the database. And so you have this replication across volunteers before it's actually considered sampled. And also statistic modeling that can look at your variance and error in there as well. And so this is just an example how we've built in training into a lot of our citizen science programs. This is our Call the Wetland program coordinator that was out there training volunteers. We also build in different identification guides and keys into our mobile apps so people can see the different species that they're supposed to be identifying. We've also built in quality controls. We've done different testing where we've put out acoustic monitors so we could compare what the acoustic monitors were recording versus what citizen scientists were telling us they were hearing as well. And then we build this into our tools where people can actually submit a photo or a sound file, so we can validate that. If people also are unsure of what they're seeing or hearing, then that can be sent in and we can validate it as well. So there's lots of things you can do to build into your programs for that data assurance. And you also need to ensure the data need is appropriate for citizen science, that not every science need can be addressed by citizen science, that there's just some things where it's not appropriate for citizen science to be collecting data. You need to think about, is the data need interesting to volunteers? You need to be able to, one, attract volunteers, but also to keep volunteers. And so it has to be something really engaging that you're getting them to participate in. And again, is the methodology appropriate? It can't be too technical or require too much advanced training. Or is it just too onerous? People only have so much time to give. And so these are all things you need to think about as you're designing your citizen science program. This is just an example, we felt Call the Wetland was really engaging because people love to be out there and see really cool things like this. This was a photo submitted by someone in Call of the Wetland. But, so some of these programs can be really engaging as opposed to, people being asked to take, well, I'm not going to suggest what some people might find engaging or others, but I think it's just really important that you think about that consideration. And lastly, it's just the importance of investing adequate resources. That while there are cost savings with citizen science, certain elements of citizen science also costs money. That through the design and implementation of this, that there's a requirement for investment of both resources and time. And that in some cases, if it's just a data gap you're trying to fill, sometimes it is actually cheaper just to go out there and hire personnel you need to collect the data. But citizen science, like I've talked about, is really about the marriage between your scientific objective and your engagement objective. And it's really about, if you're trying to achieve these dual things, that sometimes there is more of a cost involved, but then you achieve more out of it. And so as citizen science continues to grow and develop, we've seen public institutions such as the White House, we've seen it in Europe, we've seen it in Australia, and so the development of guiding principles to ensure appropriate program design and achievable impacts. And we've also seen the development of standards and protocols to support the implementation of citizen science programs. And we see this as being really important in that in 2015, the White House released a memorandum to all federal agencies that was entitled Addressing Societal and Scientific Challenges Through Citizen Science and Crowdsourcing. And it outlined like 3 principles that federal agencies should abide by. And that was that citizen science needs to be held to the same standards as Western science. It included that citizen science needs to follow open source policy. In that meaning, project data, technology should strive to be transparent, open, and available to the public. And that project should engage the public in ways that maximize both the value volunteers provide to the project and the value volunteers derive from participating. And so there's many ways in which agencies engage with citizen science. They, through small grant opportunities, development of standards and protocols, supporting training sessions, auditing programs, and that this is really important for the role that agencies play in that to actually enable citizen science. And so for some time now, there's been recognition that citizen science has strong potential to contribute to monitoring the condition of Alberta's environment, while also meaningfully engaging communities in knowledge generation and sharing. And it was seen to align with the 2018-2023 Alberta Science Strategy that recognized the role of citizen science in addressing a growing challenge to meet data and information needs about the environment. And so back in 2015, Miistakis started working, which was the Alberta government, and the department we were working with, which was then Emera. We worked with them to start to explore the role of citizen science in Alberta. And so we, back in 2015, we convened a workshop that started to look at, what citizen science is happening in Alberta, and looking at identifications of barriers and opportunities. And so through that work, this is what we found in that we did a survey. We were looking at citizen science, and what we saw is that there actually is a lot of citizen science going on in Alberta. It's going on at local levels, provincial, national, and international levels. There was a heavy emphasis on biodiversity citizen science programs, less so on other kind of environmental areas. And then what we also found in that work, so we focused on looking at some of the barriers to agency implementation. And I'm just going to highlight some of those right now. I'll go quickly here to leave some time for some questions. So one of them was just lack of leadership, in that there was, we saw that the value proposition was not well understood. Really not a real clear understanding of even what citizen science is, when it's appropriate to use citizen science, or what the role that agencies should play with citizen science. we saw that that scientists were actually questioning the quality, reliability, and in general, the utility of data collected by citizens. And those questions even continue today. And we find that surprising that because there is a quite significant and growing body of literature that shows that data collected by citizens are comparable to those of professional scientists. And so, but that is a barrier. There were also barriers related to like legal and administrative barriers. And those were around just some direct conflict with some of the grounding principles of citizen science, which are of openness, accessibility, and transparency that we found within agencies. There tends to be problems with respect to data ownership and sharing, and that often there's intellectual property challenges of when citizens are involved in data collection, of who owns that data, do they have access to that data, and that there are prohibitive public engagement policies in some agencies, that there's real restrictions around how public can be engaged. And so those were some of the barriers with respect to legal and administrative issues. And similarly to one of the lessons we've learned is this sustainability and investment, that there's investment required for program design, development, in data collection tools, data management, and volunteer management and engagement. These are all things that require investment by agencies in. And so these were some of the barriers that we found through our work with the government, in partnership with the government. And so it was recommended that the development of guiding principles and strategies would help address some of those barriers. And so in 2018, an advisory committee was established to provide strategic advice and expertise on development of principles and strategies for citizen science in Alberta. And so Miistakis, together with Alberta Environment Parks, we struck an advisory committee that included different departments within the government and different stakeholders. And we worked through the development of principles, and those draft principles were presented at a workshop that was held in September 2018. This was a workshop that brought together citizen science practitioners across the province, had international experts at it, and these draft principles were presented at this workshop, and feedback was solicited. And so what we have right now is draft principles, and there are 6 of them, and I'll just go over them really quickly here. These are them, and the 6 principles are that citizen science programs need to include a stated purpose or a scientific outcome. That needs to be explicit. Secondly, that citizen science data collection is fit to function, or that data, what that means is that data is collected using standards and protocols appropriate to the intended purpose or outcome. And that citizen science programs operate in an open and transparent manner. So again, you can see these commonalities to other principles we've seen about accessibility and openness. The 4th one is that citizen science programs, they're inclusive and encourage active, meaningful, and productive participation. And that programs are designed to provide benefit to all participants, and just talking about what that benefit could be. And that citizen science programs take into consideration safety, legal, and ethical standards and guidelines as well. So these were the 6 draft principles that are being put forward by the government. Also included in those principles, there are recommended actions to advance the implementation of citizen science, and the actions, they cover kind of 3 themes. One of community of practice, capacity and tools, and enabling use of data. and then also included are case studies that highlight examples of successful programs in Alberta that are developed in accordance with the citizen science principles and that are contributing to data and information gaps and environmental monitoring and environmental decision making in Alberta. And so these are 4 of the case studies that were included in the principles. And just some closing here, just highlighting some of the lessons that came from this process of developing these principles, is that we think this is a really important first step. It's not the final step, but it really demonstrates leadership with the Alberta government in that it would be the first province in Canada to develop citizen science principles. And we recognize the importance of really showcasing what citizen science is already happening in Alberta. There's some really great programs in Alberta and it really empowers those that are already engaged in using citizen science in the province. And we also saw the importance of the diversity in the advisory committee, that this was a very diverse group across different departments in the government that were all contributing to the development of these principles. And so just in closing here, that there's already a lot of expertise within the government of Alberta and outside in kind of the building citizen science programs and the delivery of citizen science programs, and that we see that this is real leadership on how we can collectively advance citizen science through these guiding principles to really advance environmental outcomes in Alberta. And with that, I will close and I will address any questions people have. Thank you all for attending. And I just want to highlight that Miistakis are continuing our Miistakis Monday webinars. We have our last webinar before we're taking our break for summer next week. So next week, Guy Greenway will be discussing community conserve on webinar next Monday. So you can and you can see the recording or access the recording from this webinar on our Miistakis website on our webinar page. So thank you, everyone. And if there are any questions, you can put them in the, I'm even confusing myself with instructions I gave you in the chat box, I think. So if anyone has any questions, please forward them to me. I have a question here that Dr. Alice Cohn at Acadia University is concerned that so little community-based monitoring data is used by formal agencies. Why do you think that governments and consultants might be reluctant to embrace volunteer data? Well, I think in the absence of things like these guiding principles coming from government agencies, I think that is, an important step is seeing that kind of leadership. But there are, I think it's more in the unknown that a lot of people aren't sure about how and when is most appropriate to use citizen science data. And so there's a lot of literature out there to support that now, but I do think the reluctance is just on, there's little guidance on how and when to use citizen science. There's actually a really great framework that was developed in Scotland, I think, and it walks through this framework of when is most appropriate to be using citizen science. And I think the more we have access to tools like that, I think it can help that. Someone was just asking, where do you find your publication on these principles? Well, the principles are actually in the hands of the government of Alberta right now. They were presented, they've been developed in a draft form, and they are with the government right now that they're finalizing and releasing them. So we're hoping that that is something that happens in the very near term. There's a question here, and I'm just going to read it. Government agencies like data that fits in boxes and is vetted, guaranteed without drama. I agree. They do not like surprises, nor do they appreciate the changing research landscape. Consultants like to provide the above data and do not like the fuzzy nature of CITSI data. This will change over time as CITSI gains credibility in the peer-reviewed literature. The same this has occurred in CITSI healthcare, also known as patient engagement, which I'm more familiar with. Did you know that now Alberta Cancer Foundation stipulates that research studies must have CITSI researchers engaged from day one, or the grant will not even be reviewed? Well, that's very interesting, and I agree. I think the more and that we see this in, you know, either published or just actual examples of how this is used to support decision making, people will become more familiar with it. And I think this is just a comment. Government also have larger privacy law commitments that may make a difference. I agree. And consultants can use published CITSI data, but it can be very difficult to organize on consulting timelines. Yes, agree. And I think this relates to kind of then the principles of openness and transparency that, you know, citizen science data needs to be open and freely available to all. And that's one of the kind of the principles that that's being developed in Alberta, at least as well. Well, thank you for those. Oh, one here, yeah. How is CITSI organized, I think, in the EU? They're typically in advance. Yes, very much so. So the European Union, there's a European Association for Citizen Science who actually developed principles a number of years ago. And so, yes, they're much more kind of advanced than we see here in Canada through the use of citizen science. So, yeah, but I think it provides an opportunity for us to learn from them and to use the information that they have developed. Well, thank you everyone for your questions and comments. Does anyone have any other questions? Well, with that, I will close here. And again, thank you all for attending today. Have a great day.